Hey there guys, this is the first lesson of Unit 9, Laws of Exponents, Day 1. So, just as a quick recap, don't forget that exponents tell us how many times to multiply a base by itself. Now we're going to be referring to the base as whatever number or variable we're being asked to multiply by itself. In this case, our base is 4, and we're multiplying 4 by itself 3 times. Now also don't forget exponent, we can also use a synonym called power, so we can also say this is 4 to the third power. Now, generally, there's going to be 3 laws of exponents we're going to be focusing today on day 1, which is the product of powers, quotient of powers, and the zero exponent law. Now, first things first is kind of break down these vocabulary terms. Product, we know we can use it as a synonym as multiplying, so product is another way of saying multiplying in math. And powers, just like I said, powers is another synonym for exponents. So when it tells you product of powers, what it's really telling us is that this is the rule for multiplying exponents. So generally when we're multiplying exponents with the same base, notice they both have a, well, a to the m power times a to the n power is really a to the m plus n power. So this is telling us when we're multiplying exponents, we're adding exponents. Now the quotient of powers, quotient is another word for dividing in math, and we said powers is another word for exponents. So quotient of powers is telling us what to do when we're dividing exponents, such as a to the m power divided by a to the n power. Well, it tells us that it's equal to a to the m minus n power. This is telling us when we're dividing exponents with the same base, we're really subtracting them. And then finally, we have the zero exponent law, which tells us anything, so where a is any real number, raised to the 0 power is equal to 1. So this could be 0 to the 0 power, this could be 100 to the 0 power, this could be -5 to the 0 power. Anything to the 0 power is equal to 1. Now we're going to get into the product of powers. It's specifically in this video, and we're going to go over our problem set 1, and I'll be doing the problem set 1 in column A. But first off, as a recap, multiplying exponents, when we're multiplying two exponential values with the same base, notice they're both a, keep the base the same, so notice I kept a, and add the exponent, so I added my m plus n. So here's an example. So say we're asked to multiply p to the third power times p to the second power. Well, we're going to keep the p. Now this is kind of a proof of why this works. We can rewrite p to the third power as p times p times p, and then we can multiply p to the second power as p multiplied by itself twice. Well, notice now if we recount these p's, we now have 5p, so we can rewrite it to p to the fifth power. So notice this is why it works. So yes, when we're multiplying exponents with the same base, we can add the exponents and take kind of a shortcut instead of having to do this middle part here. So here's another way we could have done it. We could have used a shortcut right away and said, oh, well, I know when I'm multiplying exponents with the same base, I add the exponents. So p to the 3 plus 2 power is p to the fifth power. So column B is going to be the ones you'll be doing on your own, but I'll help you out with the first one. T to the second power times p to the fourth power, we can rewrite as t to the 2 plus 4 power, which is t to the sixth power. You just add exponents. Whoops. Pretend you didn't see that. So the next one we have is m times m to the fourth power. Now, anytime you see a variable by itself, it has an implied exponent of 1, or an implied power of 1. Well, this we can rewrite as m to the power of 1 times m to the power of 4, which, if we know the shortcut, we'll just add that 1 plus 4, which is 5. So we can simplify this problem to m to the fifth power. Now, for example C, this looks slightly different. Notice we have parentheses now, and now we're introduced to negative exponents. You approach it the exact same way. Don't forget when two exponents are touching with nothing in between them, they're really being multiplied. So this is still a multiplying problem. And even though this is negative, you still approach it the same way. Since they have the same base, they're both x, you keep the base, add the exponents. So we can rewrite this as x to the 6 plus -2, which is just really 6 minus 2, which is x to the fourth power. So it's again, column B is something you'll be doing on your own. Now for the final 3 examples for column A, for your problem set 1, we have 3x squared, or x to the second power, times 4x to the fourth power. Now once again, we added something extra. Notice we have actual concrete real numbers now. Approach it the same way. You multiply your like terms together, so you'll do 3 times 4. Then you'll multiply x to the second power times x to the fourth power. So we know 4 times 3 is 12, so this is where that 12 came from. And we can rewrite x to the second power times x to the fourth power as x. 2 plus 4, which we know is 6. Example F, now we're introduced with negatives outside from my exponents. Well, we still approach it the same way. We know negative n squared is really the same thing as negative 1n squared. So you'll multiply negative 1 times your 2, which gives you negative 2. And we know that when we're multiplying exponents, we're really adding them. So we'll do 2 plus 6, which is 8. So this simplifies to negative 2n to the 8th power. Finally, for example example G, we have two exponents, or two variables, but you approach it the same way. So x to the second power and y to the third power times x to the fourth power and y to the second power. Just approach it kind of as if they were two problems in one. So if we had only focused on the x's, because remember, they have to have the same base. This has an x, this has an x, so these are the ones I can add. This has a y, this has a y, so these are the exponents I can add. So you'll have x to the 2 plus 4 power, and y to the third and y to the second will give you y to the 3 plus 2 power. Well, 2 plus 4 is 6, and 3 plus 2 is 5, so you simplify it, x to the 6th power and y to the 5th power. So these were examples A through G for problem set 1, column A, problem set 1, column B you'll do on their own, or if you're a novice learner, we'll do it together. So your code word for today is going to be the answer to this pun, which is, what's a math teacher's favorite type of tree? It's a geometry, but very funny. So I'll see you guys in class. Don't forget to take your pre-assessment, and I'll see you guys later.